So last week I was saying that I needed to get some code to put on a blue pill board, and the blue pill is just that little depending where you buy them and how long you want to wait from, they're like $2 to $5 a piece. That's got an ARM ST micro, so it's STM 32F103 processor on it, and it runs like 84 megahertz or something, and it's got lots of peripherals built into it. So I was saying I want to get one of those and hook up to one of my quadrature encoders, and the quadrature encoder I want to use is the one that's I think they're probably called the Chinese ones. It's got a nice ball bearing in it. It's got a 6mm shaft. This is what I have on those wheel encoders that I just mounted on my robot. So anyway, I just wanted to get code to run that, and I went back and looked at my both my Arduino installation and my ST micro installation. And it turns out I didn't have a project that's exactly what I wanted. I thought I'd just pull up a project and be there ready to go. But what I did find was under the Arduino stuff, a guy out in California with the Homebrew Robotics Club created a library to make this happen. And I was out tracking that down. Let's see how to get my. So this is his GitHub, and I'll put a link out in the thing out in the chat/info. And he specifically says it's quadrature for a blue pill, and it just consists of a header file. He's got some example code here. So if we go look at his example code, he says somewhere you can here. What does he say?
I'm seeing your green screen, not the example code.
Oh, I got to do a. Let me start back where I was. Start right here. How come I can't see? Okay, share screen. Screen 2. Now can you see it?
QuadratureBluePill. Yes.
Okay, so back to where I was. So anyway, here's his description of it, and he says somewhere here. I'm not gonna be able to find it. He says like three lines of code to get this to work. And yeah, right here. It can be done with just 3 lines of code, and you can copy from his supplied example sketch. So if you go look at his, so here's the stuff he's got. Here's the header file, and then here's the example code. So if you go look at his example code, the code consists of, you say include a header file, and then down here he starts up 3 copies of the quadrature stuff, and under setup he just initializes the serial port, and then under loop he says print channel 1, print channel 3, print channel 4, and wait 1 second. And that's the entire example. And so I'm hoping if I just compile that under Arduino with the ST micro extensions, and assuming I've got a blue pill board here with a bootloader loaded on it from my previous experiments, I should just be able to put it on there and plug the encoder into it and turn it, and then have the number show up on the screen. And if that works, the quickest thing I can do is just delete one of these down here. I could just leave it and have a third column that's always 0, but it'll just put out the three values once a second, or I can crank it up to say 100, reduce the 1000 down to 100, and I can get 10. It'll print it out 10 times a second. At that point, I could just plug my encoders for my robot into it, and plug it into my Windows laptop and start up a terminal program and say log all the data coming in, and then go out and drive around the block, and I can come back and then look at the data. So as long as I have the numbers, the raw numbers from the encoders, I can recreate all the odometry stuff. And if I think about it, I did a video one time on ROS agriculture where I was saying I drove around and here's what it looks like, and then I recreated everything in Excel so I'd analyze it further. If I think about it, I'll put that link in there before I'm done here, and that way it just by having the raw numbers, that'll tell me if stuff is working, how well stuff is working. So that's my plan on that. So now while I was out looking at this guy's how do I get rid of this stuff at the top? That's real handy. There it went away. So anyway, you go to this guy's GitHub. So if you back up and look at his stuff, he's got He's got 42 repositories. So we'll look at those. And he's got all kinds of interesting stuff in here you might want to dig through sometime. And there's the servo controller. That's probably how you just took a microcontroller, and it's like back in the old days where you had a serial servo controller. You send it command and it makes your servo work. And then here's a precision servo driver using that little PWM chip. I think Bob is the first one that told me about it. It's a 16 channel board you can buy from Adafruit, or you can find them on Amazon for a fraction of the price. And basically he's got code that will drive, I assume it'll drive up to all 16 channels. And he says it's something in Python here. So that was something that people might be interested in. This spec, I think, is he built a little robot dog with RC servos. Here's more robot dog stuff. And here's the Seat Studio AS5600. And that's the, let's see, how do I do that? Let's say stop share. And I don't know if it's worth firing up the little camera here or not. Here, let me fire up the little camera, and then I'll make a note about something I said last week. So here's my camera. Here's the top. So if I go here and say camera.
Ooh, fancy.
So that's the board. And I think they're only like $5 a piece or something if you buy 3 at a time. And this is one of those magnetic shaft encoders. So it's got a little tiny magnet that you glue on the end of your shaft. And it's like the ones Al is using, but his are 14-bit resolution. And this one's only 12-bit resolution. And I can see by looking at the edge there, it's got SCL and SDA, so it's I squared C. It's got a dir, which I assume tells you which direction it's turning, and GPO. I don't know what GPO or GP0 is. That might be an address thing, so you could put more than one of these on the same bus. But essentially, you just bolt this onto, or first of all, you glue a magnet on something that turns, and then bolt this close to the, here's an example of a finger. So you can see that it's a fairly small board.
Surprised you can't see the stencil on the integrated circuit.
Well, maybe
Ah,
it can if I try to get that. I wasn't trying to
there
get
you go. It just looked blank, but yeah, there definitely is a stencil there.
And here, let me switch over to gallery view so it quits switching back and forth. Where's my, nah, I lost my cursor. There it is, view. Gallery. Okay, so anyway, let me get to the point where I can see it. And it has to do with there's the chip number. So yeah, it says AS5600 and some other fun stuff
Sweet.
there. So here I'll go back to big view. So that's what that board is. You can buy those on Amazon. They're not very expensive. You can get, I think I bought 3 of them for $10 or $15 or something. And then back to, let's see, what am I looking at? Switch my camera back. This camera. And go back to screen sharing. Oh, so anyway, I just used that camera again. And last week I said, oh, you can go on Amazon and buy these for $10 a piece, and they'll plug right into your camera. So when I went to Amazon and searched for borescope camera, they're all starting at $20 and up from there. But they have a long cable. This one has a cable. It's about 2 foot long total. But the other ones they show the cable all coiled up there. But it turns out if you go to the top on Amazon and say, go to Amazon and say sort by cheapest listed first. And if you do that, then they get ones down around $9 and $10 is where they start. And it's got the shorter cables. So if anybody's interested in the camera, that's something I noticed. And again, I'll point out, if you're going to use it on your cell phone, make sure you buy the one that matches your cell phone. So my latest cell phone has a USB-C connector on it. So you want to order that one, and older phones still might have the micro USB. So again, just make sure that matches if you're going to buy one of these cameras. So anyway, he's got this driver here for that board, and it says he copied it from Seed Studios. He says, but this library, however, we can read the angles, get magnetic from a, and then, well, this isn't the one I was thinking. One of them, he's enhanced somebody's driver, and he's got a lot of extra stuff you can do with it. So this might just be the stock one directly from Seed Studio. But anyway, he's got that on his thing. Open robot actuator. That might be a let's see what it looks like. I was just talking about various driver boards, and so mechanics, he's showing you different ways to do it. And so this looks like an interesting thing too to dig through if anybody wants to make stuff move. He's got a write-up on all this stuff. So anyway, that's something else you can look at. And gamepad. But just in general, he's got some stuff that, to the point here. It's some robot stuff you want to see. Here's Jetson. He's talking about doing AI stuff on it. And this PCA 9685, again, that's that PWM board. And on mine, I'm using it to run my, I'd have to switch all the screen. Anyways, it runs the beacons on my mini tractor. So I've got up on top, I got some high powered LEDs. And I've got some MOSFET drivers that I bought on Amazon, and they plug into one of these PCA 9685 boards. So I can control the intensity from 0 to 100% of any of those LEDs that's on there. And so that's here he's got a driver, and he can drive from Python, it looks like. And mine is just tied into my low-level microcontroller, sending out commands to run that. So he's got here he said he's got a driver to run LEDs, and then he said he had precision servo driver as another driver that he's got. And he's got the various little LiDAR off the vacuum cleaners. Here's one just called Encoder. This one he copied it from the Teensy place. So I think Teensy has actually made it so it works on various Arduino boards with it. They don't have to be the Teensy board. So you can go look at that. And that's doing, I think, doing the whole thing in software, probably doing interrupts to make the thing work. The method I say don't use that, but that is an example of how to do that. Ultrasonics, RG pilot. Thought there was something else. So this quadratureBluePill, that's the one I'm looking at right now, and hopefully I can just load the code onto a BluePill board, which you can't see that the screen's too small. And I just trying to think, is there any more servo? So apparently you can run servos from ROS with this package. Someday we could just make up a list of all these GitHubs that have good stuff. This one's called Raspberry Pi.
Can you go back up to that ROS one that you skimmed by?
The one that was
about 4 up.
This one Roboclaw ROS? Is that what you mean, or you wanted the?
You mentioned ROS, and I looked up, and I
was
trying to
ROS Pololu Servo. So I assume that's something in ROS. You just subscribe to a topic that says set my servo, and it would. I don't know if it's using yes for the Pololu servo controller board. So it's for a specific board, but he's got a driver that will talk to that.
Got it. You were down to the Raspberry Pi one.
Yeah, that's the last one he's got. This Raspberry Pi one might be worth looking at. He's got lots of different things that you can load in. These are all different packages to make it do fun stuff. And so if you're using Raspberry Pi, you might want to dig through this. He was saying you can do he's got an SCM, what's that, secure copy is what that is. He's got, so you go to look at his list down here. He's got. Well, anyway, it would be worth, if you're running Raspberry Pi, that might be worth looking at. So I'm just saying, go look at this guy's stuff and dig through it and see if there's anything fun there that you want to use for anything. So I think I'm done here. Stop sharing.
So the first quadrature sample that you looked at, it's hardware specific for that was it F401? Was his library hardware specific for that?
He's got 2 libraries listed. One just called Encoder, and that one is the one that would probably run on any Arduino. And it, whether you got the old Arduino with the AVR processor, or you got the Teensy, or you've got somebody else's stuff, I think the code is written such that it just assigns 2 interrupt pins and it's got code to do all that stuff. So that one I think will probably run on anything. Now the other one's called quadratureBluePill. That one specifically uses the built-in peripheral inside of the ST micro parts. So that one's
Got it.
specific to any of the boards. So whether you got the blue pill or what's this one? This one has like an F401 processor on it, and then the blue pill has the F103 processor on it, but the peripherals are basically the same inside of both of them. So technically, I should be able to get to run on either one. I'm going to start with the blue pill since he says he wrote it for that and it's supposed to work for that. So
Cool.
that's what I'm going to try on that. So let's see, where were we? Oh, so the next thing I noticed was, here we can go back to the cute little camera again. And go like this, go like this. And this is my blue pill board, and it's minus a USB connector. So if we look at another one next to it, see this one has the connector on it, and this one has popped off because I left a cable plugged into it, threw it in my junk box, and that's enough force on that. But here's another thing I wanted to point out. I can adjust the light coming out. There's a little, see on the cable here, it's got this little module that comes with it. I think if I push that button, it'll take a snapshot of what I'm looking at. But it's got this on the side. You can adjust the amount of light the thing puts out. Probably if this had better lighting, this camera would work better too. So anyway, here's the same type of board. So anyway, here's the same type of board that's got a connector soldered on, and it's got just 2 tabs on the thing. And see, that's what was on here, and it snapped off because you look at it, it looks like the 2 little square pads right under it didn't get soldered at all. They were just the two tabs on the side were soldered down. But you can also get, if you pay attention when you buy these, if you look at the pictures, get this one down here in the way. So this particular one has 4 tabs sticking out on the USB connector. Now, it doesn't look like they're soldered real well. I'd suggest, any of these you get, first thing you do, take a soldering iron and get those hot and put solder on so you've got them held down. But if you get the one that's got the 4 tabs, you're going to be better off. It's going to try much harder to stay on the board. We'll put it that way. And then you've got the concept of.
Can you turn the 4-tab one over? I think those look like through holes.
They are through holes, but they don't go through. You can see them sticking through those holes there, or they're not. I don't think they actually go into the hole.
Definitely looks more secure though, especially if you dropped a dollop of solder on those.
Yeah, and if you look from the edge, I think you can see there is solder between the tab and that pad there. But yeah, if you get a big, not a big blob, but get it hot and put enough solder on to cover the tabs and the holes and everything, I think they'd work much better. Then the other ones, the newer ones, are coming out like this, and this one has a USB-C connector, and it looks like this one has, I think it's got 4 tabs, so it's got a tab halfway up, and then it's got another. Go back to the big view again. And so I think it's got tabs towards the back, and then it's got the tabs towards the front. And now this is going to show up really well due to my poor lighting. So anyway, I think it's soldered down in 4 places, and that's going to be better than just the 2. So that I think you can even buy the F103 boards. You might be able to, if you look far enough, find one of those that has a USB-C connector on it. I'm not sure, but I kept looking and thought, I don't need any more crap right now. I got all the stuff on the table here that I could be using. And the other thing was, I forgot what I was going to say. So I guess so anyway, don't break your connectors off, because once you do, that board with the broken connector is basically worthless unless I hook up to the say the UART pins. If I hook up the UART pins, then you can stop sharing. Oh, I'm not sharing. Okay. I want to switch my camera back.
No, you're sharing. Hi, it's the borescope that's on being shared.
Yeah, but that's just my regular video. I'm just switching the camera from one camera to the other. So
Oh,
so no, I wasn't sharing, and that's why I couldn't find the stop sharing button. So anyway, so don't break your connectors off. Oh, so if I do destroy that, because these boards, they have the on the end here, it's got the pins where it's got the you can hook up a debugger, and if you look on Amazon, you can find the little debugger there around $5, or you can buy, sometimes you can buy two of the boards and one debugger for like $13 or something. But if you plug these wires into that, then you can program the board without using the USB. And if you want, you can connect the just fire up a UART on the board and hook it up to either an FTDI type thing where you convert the serial into USB, or you can even put serial to RS-232, or if you're going to cut two boards together, just run wires from this board to this board and just plug them together without any adapters in there. So I can still salvage that one's got the broken connector. And somewhere it said that one of them showed extra pads for the USB connector, but I don't see them by looking at these boards here, so I don't know if I was just imagining that. Actually, they show you pictures on Amazon, and they show you pictures of it, but then you look at your boards, and your boards don't actually match that. So no, none of these have any way to do that. So I was thinking if there's a way to get to the pads on there, you could just put an extra external connectors to hook up USB to it. But I think in general, I'm just going to ignore this one unless I can run it without needing the USB connector on it. So again, I'll post the link to that GitHub that has all the fun stuff on it. And what's my latest thing? So I just quickly, and Al's going to whine about this, but anyway, I quickly started scribbling down like a graphical view of how my encoder, my odometry should work. And by the time I got to the bottom, I thought, oh, it'd be easier to just write lines of code. That's about 10 lines of code if I just simply do it that way. So anyway, I'll try to, I can extract that out of my actual robot, and I should put it into a function and quit playing around with it. So the other thing I noticed on that was every time I write this stuff, I go in there and I'll start and say, okay, I'll take encoder counts from the encoder, and somewhere through I'll convert that into a distance in meters, and somewhere I'll convert it into a speed in meters per second, and then I'll convert it back to counts, and I keep doing all the stuff. So I need to go through and figure out, starting from the encoder, so here's the encoder, here's I work across, make sure everything's done in encoder units, and then the very last thing, convert that to a distance in meters and a speed in meters per second, and a heading, and then an angle in radian, or a speed in radians per second, and all that kind of stuff. So I just need to clean that up and go through and do that. And essentially everything in between there that does all the odometry stuff should be, should we say, universal, depending on whether I'm running my quadrature encoder and that peripheral, or we take one of Al's encoders and convert that down into an absolute number. Whatever you want to use, you should be able to you should be able to swap out encoders, whatever you're trying to use, and then get the same code beyond that to get all the way to you up to where you publish an odometry message. So that's something I was thinking about. And I had one more thing I was thinking about, but I don't want to go into it right now. So we'll just say, well, what it is, it goes back to that.
Put your diagram back up. I want to see what you're dissing me over.
See, that's the point. You go, oh, well, I need to know exactly what's going on there. And it's, you're not going to know that. So the thing I was thinking about,
you're not going to put it up, are you?
No, I'm not. So every once in a while I talk about, well, what if I'd have more than one blue pill board connected together, or, have a bigger, here's another random bigger board. And I was thinking, well, you could just use the blue pill as a smart peripheral. So I was thinking, well, if I put my encoder stuff on it and then have a connection, like say UART connection between these two boards, then this board can do all my quadrature decode and just send the values over to this board. And I started thinking about, physical layout on that and how you do all this. And it again just confused me and distracted me all week. So I didn't actually get anything done on that. So that was the other thing that I'd thought about. And as I say, I held up those. I lost it now. That little shaft encoder. I want to get that running so I can use it for something. I kept thinking I should put it on my carburetor. So if I ever do the experiments with trying to do the speed on the lawn tractor, which I need to put my lawn tractor back together before I can do any of that. But if I had something that measures engine RPM, measures the speed of the back wheels, and then if I could watch the carburetor, because inside of your carburetor it's got a like a hole like that, and it's got this flap that opens and closes to control how much air goes through. And when it does that, it's just got a shaft sticking up on the top. So the shaft turns like that. So if you just glue a magnet on top of here and put the board on top of it, you can measure that position as it drives around. So you're driving along and you come to a hill, you should see the vehicle speed is going to slow down, and you can see the engine RPM is going to slow down to match that, and then you'll see the carburetor will open up due to the governor, and it'll bring the speed back up, and that'll bring your RPM back up and bring your vehicle speed back up. So in order to see all that at the same time, it would be good to be able to monitor that, and it just seems like that'd be a perfect application for that little angle sensor. So that's something else I've been thinking about, just to distract me from doing anything. So, and that so I think that's all I got right there, unless if Al has any questions of what I'm doing other than what's on that diagram.
Not going to ask because you've been clear.
Okay.
I just wanted to remind you, there's a repository that I have regarding what I just call embedded code, which the left and right speed are what runs on. I mean, I have different boards and a slightly different sensor, just happens to be a magnetic sensor, but instead of however many ticks you're going to get out of yours, this one just happens to have 16,000. And I do have ROS running on that board to put out an array with multiple pieces of data. Let's see, data that I'm putting out is just the current position. I was keeping track of total rotations, the delta ticks, which is just the change in position from the last time it published. It calculates speed in meters per second, and it publishes the delta number of meters. Some of that is redundant, but I was looking for anomalies at one time, and I thought, well, I better have all the data, and just publishes it out as an array, as opposed to just a speed topic. So I've done a little bit of, and then I was calculating G-force too, because I wanted to, again, look for anomalies and try to find where I was pulling 4Gs, I think, and I'm like, no, it's not pulling 4Gs. Anyway, more specifically about what's going on. Let's see, get over here. Oh, it went to sleep. When we last spoke, I had run mission, and the adherence to the line was not as good as I would want. I mean, you can see some places it's what you might call tolerable, and other places it wasn't. And I got to thinking about that, and there's just a slope to the terrain of the property that I'm at, and the way the slope runs is it's low here, high here, low here, high here. So when it's making this run, it is I'm going to get pitch and roll wrong, but it's leaning to the left if I'm going from south to north. So I'm like, oh crap, I'm not adjusting the GPS position based on the pitch and roll of the vehicle. And so a little bit of what I've done recently is to try to figure out how to accommodate for that, and I haven't found a perfect example to follow. Let's see, but I have been working on so whenever I have to test something, and I just have a little bit of code instead of, because I was filling up my folders with sort of short programs, and instead of that, I thought, well, maybe I'll put it in a Jupyter Notebook so I can have a little bit more description about what's going on and have a little bit more of a hope of finding it again. So anyway,
Can you make that larger?
sure, I can try. Control scroll. Does that get it?
Yep.
So anyway, I'm testing testing an adjustment to my location based on the pitch and roll of the vehicle. And one of the summaries, I looked at scrolling down to get to some text that I wrote here. So I took my ROS bag file, ran another script to pull all of the pitch and yaw data out of it, converted it to degrees, and the roll is, I don't know if it's right to say least and most, but the most negative is the negative 17 degrees, and the most positive is a positive 17. And the pitch, the same sort of, interestingly enough, if my math is right, the pitch varies as well. And so I'm like, I think if my math is right, that it could be off, close to 0.4 of a 0.4 meters, which is, sort of material. So anyway, based on that, I'm like, oh, okay, then I better work on adjusting it. So I've got what I found is some code that uses a rotation matrix, and linear algebra is, that was a long time ago. So I can't say that I'm perfectly able to test this out. And so that's why I was putting it in here and running some test data through it with these varying X, Y, and Z positions in order to test this thing out. And so the data looks reasonable coming back. When I plot it, And in this adjusting the pitch, if you look for the blue line, the blue X line, and it's going from minus 0.2 to a positive 0.3. So, a total of half a meter. So it's not going to change the world, but all I'm really trying to get after is this this particular gap, that the delta between that blue line and that red line, it seems to be, relatively constant. And I think it has to do with the angle of the terrain. So anyway, more changes to the GPS to ODOM code. And how many lines is that up to now? Yeah, 500 lines of code at the moment. So I don't know, another 50 lines of code to add to that. That's what I've got going on.
So you said you made some modifications. Is it working the way you want now, or is it still?
I've just tested the IMU software in a Jupyter Notebook on ROS bag data. I haven't moved it to the GPS to ODOM code yet, and then go out and test it. That would be my next steps.
Yeah, recently I was going through YouTube, and somebody showed like the back of a tractor and showed the lines at the angles. So I saw where somebody was doing that. It might have been on the construct is where they're talking about that. So if I see it again, I'll try to make note of that.
Yeah, thanks for that. That would be helpful because I couldn't find a ton of examples. And so I was digging through AgOpen GPS because I think they adjust their location based on the pitch and roll too. And although it's C# and it's not exactly what we're doing, I suspect the logic to adjust to the pitch and roll would be transportable.
And their stuff works. It's not like some other random person says, "Oh, you could do this or do this." These guys are taking tractors out and driving across their field, and if it's not
Yeah.
right, they work on it until it does work right. So in general, I'd say yes, you could trust the AgOpen GPS, but yes, it is in C# and it's not ROS and all this stuff. The basic
But hey,
concept should be the same.
yeah, at this point, I want to, no pun intended, follow a path that's already been cut.
Yeah.
That's what I got for recording.
Yeah, I guess I'm done too.